session. Excellent.
Yeah.
Doing this. Fantastic. Well, thanks for that. Let's make a start then, and welcome to this third of this year's Research Methods Division and CAMA consortium sessions for early career researchers, junior faculty and doctoral students. I know that lots of you will have been at one or both of the sessions last week, so I won't go through a whole background to it again, but I do just want to say again, huge thanks to the folks at CAMA. Larry Williams was here a few minutes ago. Ezgi is here from CAMA right now, looking after things for supporting this. And today's session is third of four. This one is all about topics in data analysis. And we've got three wonderful speakers. Again, like the ones last week, they're broadly following the division into qualitative and quantitative macro and quantitative micro. I know it's not always as straightforward as a division as that, but it gives a bit of structure and means that a lot of different bases will be covered. We're changing the order slightly, I think, from the one which was last week. We'll start with the macro one, which is from Mike Withers from Texas A&M University, and we're delighted that Mike joins us this morning where you are, this afternoon where I am, to talk about new approaches to instrumental variable estimation. So Mike, hopefully you'll be able to share your screen now, and I'll give you a wave when getting nearer time.
Sounds great. Thanks, Jeremy, and thanks for organizing this. Really am glad to be here with you all today and looking forward to Betty and Heather's talks as well. So yeah, when Jeremy reached out about thinking about data analysis and looking at maybe new approaches to that, I wanted to at least try to present something that is relatively new in the management field. We're just starting to see a few papers that are using this new technique. And so I'm going to be talking about a instrumental variable approach in which you use heteroskedasticity to generate instruments. And so what I'd really like to do is to first define endogeneity, just so that we're all on the same page. And certainly if you're on the micro side and haven't had as much of a discussion about endogeneity, I think you'll find that it still relates a lot with a lot of the things we talk about in terms of study design and some of the issues that arise when you're thinking about that. And then I'm going to look specifically at the instrumental variable techniques that are there to address endogeneity. And specifically, I want to focus on the requirements for IVs or the instrumental variables. And then I'm going to look at this new technique and walk you through it both with examples and with kind of the basic logic of it as well. So just to get us started, this idea of endogeneity is a pretty easy and simple concept in terms of how it works, at least in terms of the OLS estimator. One of the critical assumptions, obviously, of the OLS estimator is that the variables are exogenous. And so when there is a correlation between one of your variables and the error term, that creates what is called endogeneity. So it violates this assumption that there's no covariance between, in this case, our x sub I and our epsilon sub I. And so this can arise from a number of different factors: measurement error, omitted variable, simultaneity, as well as sample selection bias. We're going to focus specifically on measurement error and omitted variable bias. OVB or OVB has been kind of listed as one of the top problems that arises and drives endogeneity. And certainly measurement error, in particular on the macro side, can be problematic given we're often using proxy variables. But I want to focus on those two in part because they also lend themselves to being approached with this heteroskedastic approach to instrumental variables. But just to, again, kind of think about endogeneity, even on the micro side, we can kind of think about all these factors that can occur in study design that can affect internal validity as well as external validity. And so what Mayer did in one of his papers was take the Campbell threats to validity and actually set that up in econometric terms. And so you can see some of the problems that we often think of in study design can be really connected with this idea of endogeneity as well. Another way to kind of visualize endogeneity is to use these directed acyclic graphs, which we don't see a lot in management, but certainly in the discussion on causality at a broader level, these DAGs are becoming critically important from Judea Pearl's work in particular. And a lot of this derives from the idea that if there is what he calls a backdoor path between X and Y from a confounding variable or an omitted variable, that can create this endogeneity problem. So again, just another way to visualize what we're talking about when we say endogeneity here through DAGs. And I'm going to return to this and also look at one other representation of instrumental variables visually as well. So if we take an example of what we're talking about in terms of endogeneity, you can think about what is a classic example we use in econometrics, but obviously has critical implications for management research as well, looking at, say, education on wages or some factor we're looking at on wages, and knowing that there may be ability that's omitted from that, in particular managerial ability. And so if you think about this basic model, what we have here is where we're trying to predict wages. And in this case, we're saying that the data generation process is rather simple. We have education and ability. And so if we're not able to actually directly capture ability, though, that can be problematic here. And so if you think about it, there's a relationship between ability and education as well. And so by omitting that, what we're doing is saying that this parameter estimate for education, this beta sub 1, is tied to this delta sub 0, or the intercept for the ability equation. And that actually ends up creating a problem in our wages equation if we omit ability. And so what that actually ends up doing is overestimating our beta sub 1 here for education. So the parameter estimate for education is actually biased in this case because of that. This is kind of using the base terminology from the Wooldridge books in econometrics. So to visualize this a little bit differently, though, you can kind of think about it in terms of Ballantine figures or a Venn diagram, if you will, but more typically called Ballantine in the work of Kennedy, as well as Cohen and Cohen. So if we go back to that basic regression equation, if we're only able to capture education, well, we have kind of these two circles that are overlapping. We have our Y and our X here representing wages and education. And so in this case, the overlap in the circles represents the variation between wages and education, respectively. But you can see I've got this A and B set up, and this A is actually where we have variation that's overlapping with an error term. And I'm just kind of visually showing this. So this is just a hypothetical here, but what we're saying is that is overlapping with our error term, and it might be partly because there are omitted factors such as ability. And so what happens again is that same overestimate. We're attributing more variation in Y to X, and in this case, education, that should be parceled out if we could control for ability. So in terms of how we address this, the instrumental variable techniques can be critical. And this is actually from another book on causality from Morgan and Winship, which is just a fabulous book if you've not seen it. But they actually lay out how this approach is really trying to address the causal identification between our X and our Y, or they're using the common causal variable D, which you see a lot in the causal identification literature. And so what we're specifically saying here is that we can use one possible solution to find exogenous sources of variation that determines Y only by the causal variable D. So let me show you what that actually means. If we go back to this Ballantine figure, we're saying that there's this overlap between Y and X, but part of it is potentially endogenous. So we need to find a third variable, in this case, what we're going to call Z, and that's actually an instrumental variable. And so in this case, if we regressed X on Z, to get that predicted area X hat, that would actually be represented here by C and D. What we're able to then do is now regress Y on the X hat to produce an estimate of our beta sub 1 education, which is just taking that C area. And you can kind of see that that's uncontaminated from the endogeneity that derives from that overlap in A and B. You're no longer attributing more variation to X than should be. You can kind of notice this, even though it's a very simple visualization, it also reflects one of the key points about the two-stage least square approach, or the IV estimator approach, it's less efficient, and it's in part because you're using less variation from X to derive a more consistent estimate, or a less biased estimate in that case, or unbiased. And so if we go back to our wages example there, education on wages, we can kind of think about this again in terms of those Wooldridge diagram or formulas, I should say, where we're looking at education as that suspect endogenous variable. And so what we're going to try to do is find that Z variable again, where we can take our first stage model to predict education with an exogenous variable here. And in this case, we could think about something like distance to a four-year college as something that is at least external to the model and not affected by, say, ability. And then we use in the second stage that predicted value of X to get an unbiased estimate of education as well. So that's kind of the basic idea. If you look at using a two-stage least square model, you have to address the standard errors and some of those things because of the nature of the simultaneous equation. But in the general sense, it is looking at taking that predicted value from your first stage and inserting it in for your suspect endogenous variable in the second stage to get a unbiased measure of that, or unbiased parameter estimate of that. So the real problem here, though, is where do we find these instrumental variables? And there are several requirements there when thinking about these instrumental variables. First, they have to be excluded from the regression model, right? So they can't be in your focal regression model. They have to be excluded, and that's kind of the exclusion restriction requirement. They also have to be relevant, though. So they have to be a strong predictor of your potential endogenous variable, and multiple strong instruments is really optimum here. And we also need them to be exogenous. In other words, they also cannot be correlated with the error term. And some of the research that I've done with my colleagues, Matt Simidini and Travis Serto, look specifically at what happens when you have endogenous instrumental variables as well. So going back to the DAG, what we're kind of saying is we need a variable Z that is predicting education, but does not have any relationship with the ability measure. And so it again has that exclusion restriction, and there's no common causes of the instrument and the outcome, and there's no direct or indirect effect of the instrument other than how it goes through education. And so that first stage relationship is the Z on education. And that's kind of the basic idea of an instrumental variable. And so again, when you think about, well, the relevance and the exogeneity, you can actually look at these two things with different tests. For the relevance, you can use in that first stage regression model, the F statistic to at least give you a sense of how well the instruments explain significant proportion of the DV. In this case, your DV is your potential endogenous variable. And for the exogeneity, we need to ensure that it doesn't have that backdoor path, again, using the terminology from Pearl, where there's no omitted variable that's also causing Z as well as X and Y, or again, it's just no correlation with that error term as well. And so again, we do have a few tests that you can actually use here, but there is a big caveat with these tests that sometimes we often don't mention in our analyses. But the one thing is that it requires more instrumental variables than suspect endogenous regressors. So we need over-identification in our model. Once we have that, you can look at several statistics that Baskel summarizes in his 2008 paper as well. And so what we're looking to do is actually to reject each of these statistics to suggest that, yes, these instruments are exogenous. But there's a big caveat here that I'm just going to point out in 1 second as well. So where do you find good instruments? As you hopefully saw, the instrumental variable technique is pretty simple. It's just finding these instruments is more the challenge. And so it really is the major obstacle of the IB technique. How do you find good instruments? And if you only have one instrumental variable, there's a real problem that you can never be sure if it fully meets the criteria. And you can see this quote from Murray that says, all instruments arrive on the scene with a dark cloud of invalidity hanging overhead. This cloud never goes entirely away, but researchers should chase away as much of the cloud as they can. But it goes back to that test of exogeneity. The only way to really test it is to assume that one of your instrumental variables is exogenous so that you can then test and see if the other one is exogenous as well. But you're always making an assumption no matter what. And that's kind of that caveat that we obviously have, but often don't discuss in our analyses or in our studies. But this is the biggest challenge with the IB. And so, like I said, I wanted to talk about a new technique. There are only 2 papers that are in press right now in SMJ that's using this technique. Haven't really seen it in AMJ at this point, but it's actually derived from some work in the econometric space. And so this is some work that author Lewbell has been doing to introduce a new technique that is using the moments in a regression model, in this case, the heteroskedasticity, to actually identify some instruments or to generate some instruments. And so in this case, you can see it's leveraging the heteroskedastic errors. And so having regressors that are uncorrelated with the product of the heteroskedastic errors can actually produce some instrumental variables here. And so with this method, an IV or IVs are constructed as a function of the model's data. You're taking the data that you have, using the moments within that data to actually capture a generated instrumental variable. And the really nice thing about this is this method can be applied with or without other instrumental variables. I'm using the external instrumental variables, just following the terminology of Lewbell. So again, going back to that education and wages example, I'm just changing the parameters here a little bit to fit how Lewbell presents it, but we've got the exact same equation here. So we've got some set of x variables that is represented by our x prime on our beta, and then we have in this case this gamma as the parameter estimate for education, and then education in this kind of first stage also has those same x variables. And we obviously have epsilon sub 1 and epsilon sub 2 there for the error terms respectively for the wage and education equations. And so what we're saying is that there's this endogenous factor here. This U right here is actually representing that unobserved factor that we were showing in the DAGs before. And so we just have a constant here, but we have the U both in our epsilon 1 and epsilon 2, which means there's endogeneity in this model. And so that could derive from some unobserved factor again, like ability. And so to generate these heteroskedastic-based instrumental variables, Lewbell suggests that what you need to do is get an estimate of, in this case, the alpha prime. And so that's again deriving directly from our second stage, or excuse me, in our first stage of the two-stage model. And what we're going to do is use an OLS model to get some estimate of the residuals, which would be this epsilon sub 2 prime here, or hat, excuse me. And so that's equal to just our regression equation. And so then what we do is we get these instrumental variables, which are some elements of X. And then we can get an estimate of our beta and again, our gamma in this particular case for the OLS model when we look at our focal variable, which is the wages equation. So that's kind of just the basic two-stage approach here in a lot of ways, but using some moments in the data to actually pull that out. And so in this case, there are some key assumptions. The first one is actually pretty basic. It's assuming that there is endogeneity in your model, and that's exactly what those epsilons are representing, given there's that U in both models that observe the unobserved factors there. Assumption 2 is actually suggesting that there is homogeneity or homoskedasticity with the error terms in the focal regression model, that wages on education regression model, there should be homoskedasticity. However, for our first stage model where we're predicting education, we actually need heteroskedasticity, and that's how you can actually take advantage of that to produce these instrumental variables. The really nice thing is that Kit Baum and author Lewbell actually put together a program to address this. And so I want to use Stata just because that's a predominant statistical program in strategy, and it's pretty easy to use and follow some of the basic commands. In part, this actually derives from the IVReg2 model, and so it's just an extension of that. And so you can see, I've just given you kind of how to install the program, and then it's just some of the basic syntax. And you can see here it's pretty simple, where you've got your IVReg2H command with your DV and your exogenous variables, and then your suspect endogenous variable is included in the parentheses. And then you can see there are some critical options, and Baum and Lewbell both, they recommend to include both robust and the GMM2 option in the model here. And then there's some additional ones that allow you to generate the instruments from this analysis, as well as if you're using panel data. So either in the cross-sectional or longitudinal data set, this is there. And you can also determine if there are certain instruments you want to use here. So if you only want to use a certain subset of the exogenous X variables to generate those instruments, you can do that as well. So let me just show you what this looks like really quickly in the at least Stata context. And as I've noted down here, there is an R package that does the same thing as well if you're more familiar with R. But if we go back to our education and wages, so this is actually derives from some classic work from Card. And so looks at, again, how does educational attainment affect wages? And so this data has the DV being log of wages and the IB in this case, the independent variable education, completed years of schooling, and then we have a number of control variables as well. And so what I've done here is just within my PowerPoint slides, which I believe will be shared with you all, I've just included the Stata command here where you can recreate everything I've done. And so the first thing is just bringing in this data. And so this is readily available online. And that's in part why I wanted to use this data so that you could have it at your disposal. And then all I'm doing is summarizing the data just to get a little bit of a proc eyeball, if you will, on what the data looks like. And then just looking at the correlation here. And so we've got wages and education and those other control variables that we're assuming are exogenous here. And so you can see there is a relationship, at least from a correlation standpoint, between the wages and education. And then I'm just running a basic regression model here where we're predicting the wages with the education and other covariates as well. And so you can see here it's the parameter estimate 0.074 is what we're getting. We're going to return to that when we actually see the end result with the instrumental variable technique. So how do you actually go about doing the instrumental variable technique to produce these heteroskedastically generated instruments? Well, what you do again is kind of provide that or follow that command where you've got the log of wages with the education being that potentially endogenous variable, and you include those other covariates. And as I said, including those other options there. The first is just asking Stata to provide that first stage, and so that's exactly what I'm reporting right here. And so this is actually the OLS model that is predicting education, and you can see it also has those heteroskedastic-based generated instruments right here. And so this actually represents experience squared, Black, SMSA, and South. And then you can see it gives us the test to see how well it is. So again, going back to that, the strength of the instrumental variables or the validity of the instrumental variables. And then this is that second stage, which just follows from the command, and you can again see it gives you the estimate of education, but it also gives you the Hansen-J statistic that I was mentioning earlier for the exogeneity of the instruments as well. So what you've got here is, without any external instruments, at least some insight into how the issue of education might be addressed through an instrumental variable technique. Now, to test those assumptions that I was mentioning earlier, the assumptions 2 and 3, what we can actually do is first to implement the IV-Reg2 estimate to, again, just get a sense of the heteroskedasticity that's going on in that second stage model. And so in this case, you can see I just run the two-stage model with the IV-Reg2, including those generated instruments, and then just do the IV HET test or HET test, and I'm asking for it to drop the intercept in this case, and you can see, at least relatively speaking, it seems like our data at that point are homoscedastic. And then at the second stage of this, to test that third assumption with the first stage of the model, we actually can do that directly here with the regression model. And you can see here we do have heteroskedasticity going on in this case. And so one of the original insights from Card was that, well, there might be an external IV, this idea that you could use geographic variation, college proximity. But if we only had one instrument, we actually couldn't test whether it was exogenous or not. But the really cool thing with this new technique is actually you can do that directly. And so what you do is use the same code, but now you add that potential instrumental variable, the near four-year college, and include that. And you can see it's included in that first stage, but you also have all of those generated instruments in there as well. And what it allows you to do, again, is get a direct test of that. One, you can see we have the parameter estimate based on those instruments, the external instrument we had, as well as the generated instruments. And it also provides you with the statistics about whether that instrument was exogenous or not. And so in this case, you can see, at least looking at those instruments, it does seem to indicate that you can assume these data are, or excuse me, these instruments are exogenous. And it provides you with a nice little summary where it shows you the standard IV. In this case, if we only used the proximity to a 4-year college instrumental variable, then it also shows you with only using the generated instruments, and then it shows the combination, or including all of those, the generated as well as the external instruments as well. So you can get all of that information directly, which is kind of nice. So just to kind of summarize here and provide some caveats, as I was saying, the instrumental variable technique is pretty simple in its structure and how to apply it. The real problem is finding these external instrumental variables, and especially those that can meet the criteria of being strong predictors of your potentially endogenous variable, but also being exogenous in that second stage of the model. And so constructed instruments can really help with that when no external IVs are available, or when you're testing the exogeneity of your instrumental variables, when you have one external or more external instrumental variables. At the same time, though, this method does have some assumptions about homoscedasticity and heteroskedasticity at the different stages of the model. The good thing is those can be tested directly, which is nice. There are some caveats with that too, that even if these assumptions aren't met, you might can still look at this method, which is again kind of nice, but certainly I would recommend that you directly follow Baum and Lewbell's recommendations on how to approach that. And again, one of the biggest caveats here is that this method is much better if it's used with other external instruments. So it can be used without them, but the preference would be that you apply it with a combination here. And so you can see this directly from Lewbell, where more generally identification based on functional form or constructed instruments is preferably not used in isolation, but rather is ideally employed in conjunction with other means of obtaining identification. But there's a way to check robustness of results to alternate identifying assumptions and to increase the efficiency of the estimation. And so that's something to keep in mind here. The one thing I will say in my slides, I also have a number of references. Again, a few of these, which I've just kind of highlighted, are some in-press papers that are using this technique. So you can see Campbell et al. And O'Sullivan et al. In SMJ are using this technique. So we're starting to see that. But also, as I was saying, the Baum and Lewbell, as well as Lewbell's writings on this, are critical if you're thinking about using this technique, which I think could be a really helpful, especially given the difficulty in finding instruments, can be a really useful and helpful technique. But you want to understand the assumptions that are built into the model and the boundary conditions to this model as well. So with that, thank you. And I'm glad to try to answer any questions that you might have.
Fantastic. Thank you very much, Mike. That's I know it's difficult to clap on Zoom, but I think we all applaud what you said there. So yes, any questions? If anyone has a question, there's no particularly easy way of doing it, I think, on Zoom. So if you can either type it into the chat window, and this goes for the remaining 2 presentations as well. Actually, you can type a question into the chat window during the presentation. I'll come back to it afterwards, or you can just speak up now. So anyone have a question for Mike? Oh, were you saying something, Heather? I think you were on mute.
No, I was just saying there is one, I believe, in chat, right?
I might have missed one. There is, yes. Sorry, yeah, with all various other messages flying around, I missed that. So question from Rafia. Thanks to bring the Lewbell approach to attention, I have found several recent papers in energy economics have used this approach. I applied this approach as a robustness check for my paper as well. However, I would like to know that the Lewbell IV is sensitive to the choice of Z as internal instruments. Any updates and or suggestions in this regard? Also, using R packages often do not provide all of the 3 over-identification tests as applied in the 2008 paper that you presented. So a couple of different things there. Would you like to respond to that?
Sure. Yeah, no, it's a great point. This method has certainly been picked up more in the econ space, for sure. I think since the publication in 2012, I think it has over 1,000 sites already. So it's certainly gaining traction, especially within that space. You're right. It certainly can be where the choice of the internal variables you're using, it doesn't have to be all of them, right? So it can just be a subset of your X variables, let's say. And so in that case, you really could look at the first stage to at least get a sense of what's going on. I just did it directly in applying it because that's mostly following what has been done with the card data. But you could look at that and you could see that 2 of those variables weren't as strong predictors. And so you could eliminate those, and it's actually really easy to do, where you just use that Z option and you can say that I only want to look at these 3 internal X variables or whatever number that you're looking at to address that. I've not used R. I'm actually more of a Stata person here. We actually have it based in College Station. And so for me, it's pretty easy. If I have any questions or anything, I can even stop by the Stata headquarters. So I use Stata predominantly, but with that, you do at least get the Hansen's J, which actually is reported in that summary statistic as well that I was showing at the end, at the very end, where it summarizes the 3 models, which is kind of nice. They're all kind of getting at the same thing though. So, you might have different preferences for which of those you use, but in some ways they're all trying to get at the same idea as well.
Great, thank you. Any other questions anyone would like to put forward to Mike? Just while anyone's thinking of that, one sort of question from me. I'm not sure how much of it is a question or an observation, but it certainly does appear to me that the use of instrumental variable techniques is one of the biggest divides between macro and micro people in our field, in that in micro studies, they're far less used. But I think a lot of the problems with that, lots of the reason for that is that, well, it's partly that people don't know about it so much, but it also the difficulty of finding instruments, as you were talking about. So I wonder if you think what the technique you've been talking about today can help with that issue in micro studies.
I actually think it can. I was thinking about this quite a bit. We were working on another paper, a methods paper that we had published at JOM recently on a technique called the ITCV, which is looking at trying to provide some threshold of how large of an omitted variable would have to be to influence your results. And we actually talk about how that might be applied in the micro context. It really is interesting. In some ways, we use different terminology. And so I think on the micro side, it's kind of more in that Campbell kind of perspective of how you might think about study design, which I think even on the macro side is something that we have to do as well, right? If you have endogeneity in your model, if you can address it through study design, that's obviously critical. And we often in the macro side think about how we can address all these problems with our data after the fact using econometric techniques, right? And so I think we're kind of having similar conversations. It's just on the micro side, sometimes it's more focused on doing it through study design. With that said though, Jeremy, I think your point is well taken, and certainly John Antonakis has been someone who's really tried to advocate for thinking about endogeneity in the OB literature and OB and HR literature on the micro side. And the really interesting thing is that, yeah, with a technique like this, if someone says, well, I think there might be a confounding variable, or I think there might be an omitted variable, what they're really saying to you is, well, you might have an omitted variable, right? You might have something that's going on there. And I know one of my colleagues here is using ESM studies a lot now, and in part why I think the micro researchers really went to that direction to a degree is at least that you're trying to take out some of that between variance, right? That between unit variance that could be endogenous, but you're just using different terminology to say that. But by focusing specifically on kind of that within variation, you can do that. But there could still be some time invariant endogeneity, or excuse me, I should say time-varying endogeneity in that case, that could be there. And this technique could be applied in the micro context pretty easily. And I will say, if you're more, say, M+ or even SPSS or something like that, Stata is actually pretty easy to use as well. So that if you needed to switch over, it actually, in a very similar way to SPSS, can be used point and click, or it can be with the syntax that I present in my slides. So either way, it makes it pretty user friendly. So absolutely, a long answer to really make a short point, which is yes, I do think it could be applied directly for the micro side as well.
Sure, I can vouch for what you're saying about being able to pick up Stata, because until a few years ago, I hadn't used Stata at all. I'd used SPSS, I'd used R, used M+, and for one or two things I needed to start using Stata, and yeah, it was not at all difficult to pick up. So I'd commend what you say there. And Rafi's just saying that he's used this approach with cross-sectional data with time information of about 600,000 observations, which sounds pretty impressive, and it works well for him. Great. Unless there's any more questions for Mike, we'll pause that there and say thank you very much, and we'll move on to our next presenter, who is Betty Jo, is going to be talking to us about centering in longitudinal data analysis.
Thanks, Jeremy. I think there's one more question in the chat from Mike.
Oh, sorry, yeah, one came in just as I was finishing. Okay, thank you. Yes, I think Lewbell's approach seems to suggest a recursive model. In other words, Y1 depends on Y2, and Y2 depends on Y1. I'm curious if this approach would be allowed in management studies. Mike, I'll hand over to you for that.
Yeah, so if you look at specifically the Lewbell 2012 paper, he actually lays out, and it's a triangular model is what he's kind of talking about, but then he takes that and actually takes it to the context that I was showing. So the actual system of equations that I was presenting there was directly from the Baum and Lewbell. So it actually does have that direct application where you could be in that space of looking at what would be more where the error terms are almost related in both those two equations in those two stages. So again, I do think this would have some direct applications, and it would not be too dissimilar from what we would expect even in that economic space as well, that Lewbell is kind of more focused on in particular. He actually has some research on juggling even that he does, so it's within that context. So no, I think it would have some direct applications in management, and it pulls over directly.
Okay, that's great. And also apologies to Rafi. I think I might have just misgendered you, said him rather than her. So sorry about that. Anyway, that's great. So we will now go back to Betty and hear about centering.
Can you guys see my screen?
Yes.
Okay, thank you.
Although, yeah, that's great.
Okay, so in the next 20 to 30 minutes or so, I'm going to talk about this issue that's actually long-standing in the micro research, but hasn't been addressed until in recent few papers that's coming out of the methodology, micro methodology literature. So we're going to talk about centering in longitudinal data analysis. Here's an outline of this brief presentation. First, I'm going to talk about why does this matter? Why is this something we should think about, and why there will be important implications? And then I'm going to introduce two recommended approaches for centering predictors in longitudinal data analysis. One is using the observed unit mean or cluster mean. The other one is to use a latent unit mean. And then I'm going to talk about a related issue. It's not the same, but also often gets confused with centering, which is detrending. And then I will save some time for Q&A. So why does centering matter? Let's take a step back and think about the purpose of longitudinal research. As summarized in this review by Linda Collins, longitudinal research, if it's well conducted, usually is characterized by three themes, including well-articulated theoretical model and the design that is able that enables the researchers to capture what is going on in the process. And then also use a statistical model and analysis that is a direct operationalization of the theoretical model. So here I highlight two components, the theoretical model and the operationalization of the theoretical model in the statistical analysis. So later in the presentation, a lot of questions is really up to the researchers to answer, because how you specify your statistical model, how you choose it, how you make your analytical choices are determined by what you're trying to test based on what you are theorizing. So in micro OBHR research, when we use longitudinal design, usually we're trying to test some sort of theories about changes. And the first layer that's very common is to talk about what is intra-person or intra-unit, for example, intra-team changes. And these kind of changes that we often theorize maybe about there's some changes in the levels of a continuous variable. For example, knowledge may be going up and down in a particular, knowledge may be growing in a particular domain, or it can also be transitioning across different categorically different states. For example, we may be curious about how workers transit across employment and unemployment, or from employed to retirement, or maybe going back to the workforce. And we also may theorize the form of the change. For example, in a lot of growth model applications are trying to test theories about linear or quadratic or other form of change over time within a person or within a team or within some other units. And sometimes our theory is concerned about how does a particular variable's prior state influence its current state. For example, maybe some type of malfunction behavior, drinking may carry some inertia or carryover effect, or some other things may be stable or more or less stable over time. And some of our theories deal with cycles in a particular variable over time. Does it show any temporal pattern? And sometimes our theories about within a particular unit, for example, within a person, how do we react to things that's coming up and going away on a temporal basis? And a lot of theories in micro OBHR research also concerns about how do we explain between person differences or between unit differences in these intra-unit, intra-person changes. For example, we may be curious about whether some individual differences will be able to explain the association between two within person variables relationship, or maybe a person's reaction to particular stimuli is stronger or weaker depending on their individual characteristics. Sometimes we may also be interested in identifying subpopulations based on their different reaction patterns. And this is also another way of identifying interperson differences in the intraperson changes. And taking a step further, some theories may be concerned about explaining these intraperson differences or studies the long-term or short-term consequences of the changes. And some of these explanations or the consequences may deal with time variant or time invariant effects. And there are even more complicated models that directly try to address how does the process unfold over time. So two critical things here are to differentiate the within person or within unit changes and the between person differences in these intraperson changes. And that's one thing we see a lot of more recent research in micro side often trying to be explicit about. As Mike was mentioning in some recent micro OB research using experience sampling method, the concern often is looking at the within person relationships. And sometimes building on that, researchers may be curious, what is the between person differences in those within person relationships? So the reason of articulating our theory is really to provide a very clear guidance on how we set up our statistical model. And centering is one of the statistical analysis choices we have to make. And the ultimate goal is to allow us as researchers to specify a statistical model and then estimate the coefficients in the model so we can separate clearly what is a within cluster and the between cluster relationships between two variables we maybe care about. Sometimes our theoretical focus is only on the within cluster relationship, sometimes only on the between. But regardless, we want to have a quote unquote pure test of the effects we care about theoretically. For example, we may want to separate and clearly identify what is the within person and the between person relationships between a person's affective state and their behavior. And also that's at the within person level. And also at the between person level, what is the trait affectivity and what is the person's behavior pattern. So because of this goal we want to achieve, it's often recommended in both micro and macro methodology literature, we should stay away from grad mean centering the predictor or using the raw scores of the predictor, because when we take this approach, we will end up with a coefficient estimate of the predictor that's actually a mix of both within cluster and between cluster effects, which may not, often the time is not identical. And only when they are identical, then when we use a grad mean centered approach or the raw score, we will not result in any biases in the coefficients we receive. And here's a numeric example just to further illustrate that point. So let's say the data we have from 3 participants are generated by 2 mechanisms. At the between person level, there's differences between their personal means on both variables, and then the person level means has a positive relationship between each other with these 2 variables. And then the other mechanism that generates data is the within person differences. For example, X can be some sort of stimuli that goes up and down, or sometimes shows up, sometimes doesn't, or it has different level of strength depending on the time as time goes by, and Y will be the behavior reaction. So let's say the other data generation mechanism is a within person association of a reaction to the stimuli. And then we will see for each person here, just for illustrative purpose, there's a negative association. So assuming these are the 2 data generating mechanisms, or quote unquote are the theoretical mechanisms in our theory, then it will generate a data that looks like here on the left hand side. If we take this raw data set we're going to receive and just analyze it without considering teasing apart the within and the between person relationship using centering, then we will end up having a coefficient that's a mix of the within person relationship, which is negative here in this example, and the between person relationship, which is positive as shown here in this example. And you will notice this mix is actually not a direct combination, let's say equally weighted between these 2. It's a weighted mix that's considering some other factors that I'm not going to go into the mathematical detail, but in the reference section, I have some papers if you want to see the further decomposition. But in general, the recommendation is if you are not sure the within person and between person or within cluster and between cluster effects are identical, using the grad mean centering approach, or which is equivalent of using the raw score, will give you a coefficient estimate that's a mix of both, which in other words will not allow you to clearly test your theory that either is focusing on the within or the between or both. So assuming we're on the same page that centering is important and the goal is to tease apart the within cluster and the between cluster relationship, then how do we do it? There are 2 industry standards based on recent methodology research. The first one is to use the observed cluster mean. Let's say the cluster is a person, then you use the observed person mean to center the predictor variable and use that as your level 1 predictor. And then include the group mean or the person mean, the cluster mean back as a level 2 predictor. When you set up your multi-level model this way, then you will have an estimate of the level 1 predictor's effect as a pure level 1 effect, and you will be able to also, if your theory cares about it, you will also be able to directly test what is a between person or between cluster relationship by looking at the coefficient associated with the level 2 predictor. That's the group mean. An alternative that's sometimes also used when the theory does not, when the theory assumes there is a within cluster relationship that is fixed, or for some other reason that is the focus of the research, then you can also use the uncentered level 1 predictor and then include group mean as a level 2 predictor. In this situation, you will also be able to obtain an accurate estimate of the within cluster relationship, and the between cluster relationship obtained from this setup is the contextual effect, but there's no bias in this particular effect. You just have to do some transformation, or if you care about not just the contextual effect, but the between cluster relationship. So this approach is pretty easy to implement, and as you can see from many publications coming out in recently top tier journals in the micro area, is using this approach. The limitation, and I put a quotation mark here, is because the limitation sometimes is driven by the assumption. Maybe it's possible your assumption is met, and then there's no longer a problem. So the main limitation here is when you use this approach, you're assuming the observed group mean is an unbiased estimate of the true group mean. the assumption may not be met due to various reasons. For example, there's something systematically off in the sampling process, or there's response biases, or there's a large amount of missing data, or the unit is very small. The amount of data you obtain compared to the unit size is very small. And this will result in the bias in the estimate in various ways. For example, it may result in biases in the estimate of the between cluster relationships, especially when your cluster size is very small, and cluster size in this context in longitudinal research is a number of repeated observations per cluster. So that's the first approach that's almost a gold standard. Many papers, I would say the majority of the papers in micro OVHR research use this approach, including my own research. And the second approach, which is relatively newer, is called the latent mean centering approach. So what you do is you will use the latent variable approach, the ACM approach, to estimate a multi-level model. And when you take this approach to estimate a multi-level model, you automatically decompose the variance in the observed variable into the within cluster and between cluster components. It's purer in terms of separating the various components into different levels. And latent mean, which by definition is a level 2 variable, which will be specified as a latent variable in the model. And what is left at the within cluster level are pure level 1 variance covariance components. So when you try to model their relationship, it's not going to include any of the cluster level effects. Here's a visual illustration of what variance decomposition in the latent SEM approach is trying to do when you apply to multi-level modeling. So let's say here you have a variable y, and you collect the data on this, and you have the values on the observed variable, which is the box here in the middle. And when you set up the model, set up this multi-level model in the SEM framework, you're essentially saying there are two latent variables that's driving what you observe. One is the cluster mean, which is a latent variable at the level 2 at the between cluster level, and the other one is the fluctuation around this latent mean at the within cluster level. And these two components together will be reflected in this variable you observe. So if you put it into an equation, then y sub ti, which is the observed value at occasion t for any person I in this data set, will be reflecting two forces, or predicted by two things. The first is a latent mean, and the other one is a within person fluctuation. And the same idea can be applied to bivariate, a multiple variable scenario. So when we take this approach, similarly, we will decompose each variable's variances into the between cluster latent mean and the within cluster components. And once we decompose variables in this way, we can start to specify their relationship at two separate levels and not to worry about the within cluster relationships will include any between cluster components, because by decomposing the variance in this way, the within cluster variance covariance measures no longer include any of the clustering effect. So when we obtain estimate between variables at the level of within cluster, we're pretty confident these are the relationships that's only at the within cluster, within person, or within team, within any sort of cluster you theorize. So this approach is pretty easy to implement if you're used to conducting multi-level modeling using a SEM framework. So on the positive side, it's clearly separate the within cluster and the between cluster components. So it effectively addresses biases in estimates due to differences in the observed and the latent mean. And the limitation, again, put in quotation mark because it's more of an implementation issue, is when you use this approach, it requires you to use an analytic framework and also an estimation method, or if you can think about it as a software that will allow you to estimate a latent variable, estimate a multi-level model that's set up following the latent variable approach. And as Jeremy was mentioning earlier, a lot of micro researchers using M+, which is a web software that's able to conduct this. So you may be wondering, how do these two approaches compare to each other? When should you use both? Unfortunately, the answer is not so clear at this stage. As I mentioned at the very beginning, this is an issue that's long-standing, but just recently got picked up by methodologists, and there has been waves of simulation studies that's trying to compare the performance of these two approaches. I listed here a few papers at the bottom, which are some recent simulation studies that's published in the methodology literature, try to compare their performance. And it's really a function of multiple factors. including what is the cluster size, and since it's longitudinal research, it is the number of time points per cluster. For example, if you're following a cohort of individuals over time, it is the number of repeated measures per person you're able to obtain. And then the second factor is the number of clusters. So what is a level 2 sample size? For example, if you're following a cohort of individuals or workers, what is the number of individuals you have? And then it also depends on what type of effect you're trying to estimate. Are you more concerned about the within cluster effect or between cluster effect? Are we talking about the performance on estimating the covariate effects or the autoregressive effect? Or is the effect random or is it fixed? And another thing that introduces another layer of complication here is what type of estimator you're using coupled with these other factors can also make a difference. Are you using maximum likelihood or are you using the Bayesian approach? And then there's a host of other factors. For example, is your longitudinal design balanced, which means every single participant goes through the schedule at the same time, or is it unbalanced? What is the amount of missing data? If you're Bayesian, how are you choosing your priors? All of these together can affect the performance, which includes both biases in the estimates and the efficiency of the estimation method in the final effects you're obtaining. So there's no clear answer. So far, based on these simulation studies that's already out there, that's published, seems like the latent approach is more flexible and also better. But there are also some other combination of these factors where the observed approach may perform better. So that's about centering. Another issue that's surfacing and caught attention from micromethodologists is centering is also coupled with detrending, a term that's actually a thing that's been discussed a lot in the macro type of research on longitudinal data, for example, time series analysis. So how are these two things related? Here's a simple numeric example. So let's say we collected data from 50 individuals and we know, and we do see in the data, there's no trend in any of them. So that's what is illustrated here on the left-hand side. So you have 50 individuals, none of them trend. Then the between person difference is what is the average level of each person. Let's say we take out one person's data and plot it on the right-hand side. And for this person, when we are saying we're doing group mean centering, or person mean centering, cluster mean centering, we're really just subtracting each individual observation from the person's average level. And that's a very straightforward application of centering, which is not really that different between longitudinal research and cross-sectional multi-level modeling. But the situation can become a bit complicated when we consider the trend. Since we're doing longitudinal research, it's very possible that there's some sort of trend either in the predictor or in the outcome. Let's say, again, we collected data from 50 individuals and they all have some trends of themselves and they're not identical. And again, we take out one individual's data and plot it on the right-hand side. So here, when we again are thinking about centering, then we need to take a step back and ask ourselves, from where are we centering from, right? So the first way, which is the gold standard in cross-sectional multi-level modeling, is to center from this person or this cluster's average level over time, which is the red arrow here. But the other possibility here is to center from this person's own trend. And when the trend is considered, just taking this particular this spot as a particular example, then it may not be the identical amount as we compare centering from the trend versus centering from the person's average level. And based on simulation studies and analytic analysis, we know these are not identical choices. So what should we do? So first, whether we are detrending, in other words, considering the trend or not at all, is really a theoretical choice. Because again, goes back to the very beginning of the presentation, we want to make analytical choices that's corresponding with our theory so we can accurately test the effects of theoretical interest. So if the theory, let's say, is concerned about the within cluster relationship between two variables after times effect is accounted for, which is explicitly pointed out or specified in your theory, then it makes more sense to detrend from the predictor, especially the predictor or the predictor and the outcome. So we can have a pure test of the effect of the predictor after the trend has already been taken care of. So let's say that's what your theory is, then detrending makes sense. It's also possible sometimes we do longitudinal research to be explicitly curious about how this trend explains things. For example, we may be conducting an intervention study and our theory says the intervention will first change the slope of x, and then the slope of x will in turn change the slope of y. Then if your theory is concerned about this type of relationship, then after you detrain the x or detrain or both x and y, then there's no way you can test your theory anymore, because the most effective component in the data that reflect your theory, if your theory is working, has been taken away in this first step. So in that case, detrending is not needed, because what is included, the trend that's included in the x and y is actually what is going on in reflecting your theory and if it's working. So if your theory says you do need to detrend to more accurately test the effect of theoretical interest, there are two ways to do it. The first way, which is proposed a little bit earlier by Curran and Bauer, is it goes through a few steps, which resemble to some extent to the instrumental variable approach Mike was explaining earlier. Totally different thing, but the idea is a little bit similar. So you're trying to create a subset of a variable that's purer to allow you to test the things you want to test. So in the first step, you will fit a growth model to a predictor to test whether there is a trend in the predictor. And then you will fit a regression. If there is, then you will fit a regression model for each unit, each cluster, with the grand mean center time as a predictor. And then you will be able to obtain for each unit, each person, for example, the estimated intercept and the estimated residual. And you will use the estimated intercept as a level 2 predictor, and you will use the estimated residual as a level 1 predictor. You can think about that as a centered predictor. And then you will use the adjusted level 1 and level 2 predictors to continue in the multi-level modeling. A few years later, there's an updated method to handle this, which is easier to implement and an extension of the current Bauer approach. So you can include the random effects of time in your analysis as a predictor of the outcome variable, and then use the group mean centered option for the x variable you're curious about. And when you set up your model this way, you will be able to account for the effect of the time. So when the estimate you obtain for the coefficient for the centered x variable will be a pure estimate of the relationship between the two variables after time is accounted for. And if you're curious, this article provides a very clear explanation of how this approach achieves this through both simulation and analytics. So in summary, we talk about a few things. First, there are two recommended centering approaches. The first way is to use the observed cluster mean centering for the level 1 predictor, and then use the observed group mean as a level 2 predictor. This way, you will be able to obtain the estimate of the within cluster relationship and the between cluster relationship and have them clearly separated. The second approach is to use the latent SEM approach to estimate multi-level model. And when you take this approach, the model will first decompose the variance into within cluster and between cluster components. Then your within cluster relationship between x and y will be the pure estimate of the relationship at the within cluster level. And the performance of these two centering approach is a function of multiple factors. Based on the simulation studies that published so far, it seems the latent approach is more recommended by the researchers who's done the simulation. However, the caveat here is it's really not clear which one is better when you have a very small cluster size, which is the number of repeated measurements you have. So when we have readouts from small cluster size data, we really want to do a lot of robustness checks, and we also want to interpret the results with caution. And related to centering is detrending. So detrending choices should be guided by the theory to be tested. If your theory clearly says you are concerned about the effect between x and y after trend is accounted for, then detrending is needed. But if your theory does not have that particular component to guide you to do that in your statistical analysis, then detrending is not necessary. When your theory says detrending is required, then you can implement the one-step approach, which would allow you to take care of the trend effect, and the estimate you obtain for the predictor will be the relationship between the two variables after trend is accounted for. And here are some further readings in case you're curious about these different approaches. And with that, thank you for listening to the presentation, and I will take questions.
Fantastic, thank you, Betty. That was wonderful. I don't know how many years I've sat and listened to different talks about centering and so on. It's at least 20 years, and yet I still learned a lot from that I hadn't heard before. So that's brilliant. We've got a couple of questions in the chat. First of all, from Adam, who says, "Hi Betty, I'm curious if you, or anyone to your knowledge, have compared variance estimates for the latent mean approach in SEM to, say, the approaches provided by Snyders and Bosca or Kreft and Delau." Do you know about that?
Yeah, I can take that. And thanks for asking that. I actually got asked this question in one of the recent papers by the reviewer. So if I understand correctly, I would assume you're asking when we decompose the variance in the intercept only, the null model. And yeah, I see you nod your head. So mathematically, it's the same equations. It's the same set of equations. So you're estimating the same mathematical model, but it's possible you will obtain different estimates. Very small, it should be estimates from different type of software. It's because they may use different estimator. And of course, since it's a random process, sometimes the random seed may be different, but it's mostly the difference in the estimator. If you use the multi-level package in R, I think the default estimator is restricted maximum likelihood. But if you use N+, let's say it's maximum likelihood. And some other software may have some other estimator. So if you can look at a menu of the software and know what is the default estimator, and if it's not the same across different software, and you manually override it, because all of these will allow you to choose estimator, then you should obtain identical results.
That's great, thank you. And a question from May, should we group mean level 1 control variables, I presume group mean center level 1 control variables like employee age, and grand mean level 2 control variables like leader age in the multi-level model? So it's all about control variables. Does the same rules apply to them, basically?
So yes, for example, control variables, for level 2, the between cluster level, the choice is pretty simple. You can just think about it as any single level regression. So you will grand mean center the continuous variable, especially those that you don't really care about where is a benchmark, you're trying to interpret the results, and you will not center the categorical variable. Just follow the recommendation from Cohen et al. For any simple single level regression. But if it is a continuous variable that has some meaningful 0 points, you can also choose not to center it, but just be careful about your interpretation, just like how you would interpret any single level regression model. For the level 1 control variable, if your theory, sorry to go default back to theory, because a lot of these choices is really to allow you to test your theory accurately. So if your theory pretty safely says these other things, these other factors we want to just control for has both within and between components that's affecting the outcome variable, and you don't care about either of one of those, then you can use grand mean centering. Because grand mean centering, even though it sounds like a villain because it's a mix of within and between person effect, but if it's a control variable, it will allow you effectively to take care of both. Of course, if you really want to be very clear in your presentation of the results, because one person's control variable can be another person's trigger. You can also group mean centering the within part and then include the cluster mean back into your equation, and then so you can clearly separately present their effects. So that's what I would do.
That's great, thank you. That's very clear. So another question is from H. Lee. May I ask for a reason to use random versus fixed effects of time in the one-step approach?
Yeah, so in the one-step approach proposed by Wang and Maxwell, it's to use the random effects of time to effectively take care of the trend mostly in the predictor variable. Because when you use fixed effect of time, you're assuming everyone follows the same pattern, which is an assumption that may not be met. So if you use a random effect of time, then you're also allowing these trends to vary across different clusters, different participants. If you're not sure in your data what is really going on here, you can also try these two different things and then present the results as robustness test results.
Fantastic. That's really helpful as well. I know that there are all sorts of questions, and a lot of these answers will depend on particular situations, but it's lovely to get nice, clear answers to some of these questions when they come up like that. Any other questions for Betty? No? Okay. Well, in which case, let's say thank you very much, Betty. Great presentation, and thanks for doing that. I know you've done this before, so it's wonderful, especially to have you back at the consortium. And we'll move on now to our final talk of the day, and this is Heather Vo from George Mason University, who is going to be talking about qualitative analysis, but in recognition of the fact that a lot of the people on this session will be perhaps more familiar with quantitative work, Heather came up with the idea of talking about things to look for and to avoid in qualitative data analysis, which could be of use both to those of you who are qualitative researchers and those of us who aren't, but may well read it and review it and supervise other students who are using it and so on. So this is really something I'm looking forward to a lot. So Heather, over to you.
Thank you so much, Jeremy. And thank you for organizing. I know this is no small feat to get everybody in the same place at the same time. So I really appreciate it. Before we get started, I am curious really quickly, if you could use the reactions button and give me a thumbs up if you either have done qualitative research or anticipate doing qualitative research at some point. Okay, I've seen some thumbs up. That's good. That's good. All right. Okay, we're probably at about maybe a third of you, but that's actually more than I anticipated, so that's great. So as Jeremy mentioned, I am really coming at this from sort of a reviewing perspective, mostly from my capacity as a editor. And so I really want to help everybody feel competent and ready to review qualitative papers. So as a roadmap for what I'm going to talk about today, sorry, I know the screen might look a little funny, sorry about that. I just want to start with an overview of a general process that people often use when they're doing qualitative research, just to get us all on the same page so we all understand what I'm talking about. And then the next 3 points are about sort of complications in the qualitative process and things that you want to think about as a reviewer for a qualitative paper. And I do think that these are also helpful for those of you doing qualitative research, so you can think about what are the reviewers maybe going to be looking for. And then my final point is really that the assessment of qualitative analysis is not just in the method section, but we can also assess it based a bit on the findings. All right. So this is just a very high level overview of a qualitative research project. So you go in, you collect some qualitative data, be it any type, it could be interviews or archives or news sources, whatever. And then you do some analysis of it. This could be coding, it could be memoing, like making notes to yourself about it, comparing and contrasting different cases that you have, making timelines, all sorts of different processes go into the analysis. And then as a result of that analysis and integrated with that analysis, you do some theorizing and try and take that data and build models from it. And in that process, you also need to link it to prior literature. So almost any qualitative paper that you read is going to say this is an iterative process. The word iterative almost always comes up. And as you'll see in that model that I have up there, there's a reason for it, right? There's arrows connecting all of these 3 stages. So it really isn't a linear process. So you collect some data, you do some data analysis, you go back, collect some more data, do some more data analysis, maybe begin to theorize, but then your theory says, oh, you need some other data. So you go back and collect it. So it really is this very sort of messy, ongoing process that isn't straightforward. So this gets to my first kind of point about getting messy. So there's a little bit of a tension for authors writing about their qualitative work, is it really isn't a linear process, but they don't have 100 pages to describe the real process that they use to do this qualitative analysis, right? You've got limitations in a journal, but at the same time, readers do want to know what you really did, right? Like just saying it was this very linear, straightforward process doesn't really do justice to the research and the work that you did. And it doesn't let the reader know, what qualitative research really entails. So there's sort of a tension or complication there. And I think as a reviewer, it's okay to push the authors to be less linear, to say, okay, is this really what happened? If they're depicting this very straightforward process, I think it's okay to, push them a little bit and ask for more messy. So this is a figure actually that I adapted for some of my work, but it is based on Harrison and Rouse's piece in 2014 in AMJ. And I really like this picture because it's not an analysis picture necessarily, but it's a picture of the process. And you don't really need to know read the small print. But what it does is if you see these 3 bars, it talks about this data collection, data analysis, and sort of literature review theorizing part. And it shows how the authors moved between these parts in the course of their analysis and data collection. So for example, in my paper, we started with a research question. We went and did round 1 of interviews. In those interviews, we did an analysis, and there were some new themes that emerged that led us to go back to the literature, and we gained some more insight. Then we went back to the data collection for round 2 interviews, did another analysis, got some new insights, did more interviews, did final analysis, and kind of got to our general model. So I think this is a really nice sort of concise way of showing what really happens in a more transparent and realistic way for qualitative research. So I'm not saying that all papers need to have a version of this model, but if you see an author kind of struggling to articulate their process, you might want to send them this direction to say, have a look at this and see if that could be helpful to you in how you want to talk about what you did. And one thing I want to talk about in particular that I think is very important for people who are not qualitative experts, but are reviewing qualitative papers. And by the way, this happens a lot. As an editor, I do send out papers to people I know are not qualitative people, but they're experts in the field. There's not always 3 qualitative experts who are also content experts, on any given topic. So it is possible that you will get a paper that, is very qualitative, even if you're a very quantitative person, but is on your topic area. And so what I think your role here is, especially in terms of sort of the analysis part, it's more general than that, but you need to assess, okay, do the authors seem to have a good understanding of what came before? Like, do they know the literature, right? But also, are they letting findings emerge from their data, right? Are they not sticking so much from the existing literature? And this is also a warning to you as a reviewer, that as quant reviewers, I think we want them, sometimes I think people want authors to have pre-existing labels for everything that's found and really put it into pre-existing frameworks, but that's actually like the opposite of what qualitative research is trying to do. It's trying to expand and develop new frameworks and new ideas. So you have to let the authors, let them draw on their actual data so that new ideas can emerge. But very much, if you think that they haven't given correct, recognition of the previous literature, definitely bring that up and make sure that you acknowledge that they acknowledge what's come before. And another red flag for me is when you're looking at qualitative data, if an author is too wedded to a particular theory or something. So let's say that an author's looking at justice and they say, well, there's 4 types of justice that emerged from our data, and they are perfectly aligned with the types of justice we've seen before. Okay, well, you might not be letting the data speak as much as you could. You may be too wedded to pre-existing frameworks of justice, but also you're unlikely to be contributing something new in that space. So I guess my warnings are twofold, or my advice is twofold. One, give your expertise, use your expertise to help them along, but also don't insist that they're too close to the data and that they're too close to existing frameworks. And, it's okay to criticize them if they've drawn too much on existing frameworks and there aren't new things that have emerged. Okay, so my second point is around this idea of taking the leap. And what I mean by this is fundamentally, as a reviewer or as a reader, you need to understand how the authors got from raw data, from A, all the way to this theoretical model that they have built. Okay, and so very frequently what I see is authors stop kind of halfway. They tell you how they did their coding, so they get to that, data collection and coding process, but then they don't really tell you about how they got to the theory and the findings and this model. The model that they ultimately build. So a question to ask, and I find myself asking this in almost every paper that I read, is how did these themes that you identified ultimately become a model, right? And so maybe one way to illustrate this is through this sort of Joya model. And I'll talk about templates in just a second. But this figure here, you're going to see in a lot of qualitative research. It's kind of like I said, the Joya approach to coding. And what it does is on the left-hand side, it's sort of the raw data. What did we see like directly in the data? And then in the middle column, it's some abstractions of that data, like some categories and codes that you use for that data. And then on the very right-hand side, it is like abstract dimensions that categorize broad sets of the data. This is just a very pared down version of the Joya model. They usually have like 6 or 7 themes or 6 or 7 aggregate dimensions at the end, but just so that you could actually read it or get a sense of it, I just included these 2. And this is fine. It's absolutely fine to include a Joya model. Sometimes reviewers will ask for it. But it does tend to look sort of linear. It does indicate this sort of very linear process of I went from this to that to that. So, so that's one issue with it. But the other issue of it is this is not the end of your analysis. Getting to these aggregate dimensions is not the end of the story, right? You're not just going to, or you shouldn't, be writing just a list of findings. We found this, then we found that, we found that. No, you're putting them all together into some sort of coherent story. So things that I push my authors on, and that I think are fair for you to push the authors on, is are they really describing how these ultimate codes or aggregate dimensions become a model? So some things that they might be doing, but they don't know they're doing or are not expressing it, is perhaps as they did analysis, they realized that one theme was sort of the central theme. And then they used this theme and explored how it related to all of the other themes. And that's totally fine. They just need to explicate that, right? That this became the center of our analysis. And then we did an analysis showing the relationship between this and other themes. Another thing that I ask authors to do sometimes is to think about the turning points or the aha moments that they had in the data analysis process. Because for any of you that have done qualitative research, it's often what you find is not what you go into, what you think you're going to find in it. And so I think it's great if authors can say, we started with this, but then as we did analysis, we have this insight that really changed the course of our analysis. And so if they can articulate that process, I think that's going to give you a better sense of how they really got to the model that they ultimately are looking at. And I just want to throw out there that there is a paper in Press, Girdle, Antony, and Holm, where they talk about the 8 different analytical moves that people often can use during qualitative analysis. So it's helpful for both people who want to do it, or maybe people who want to give advice to reviewers about how to articulate their process. I did also want to give you an example. This is from Kahn and Rouse and Press at AMJ. I'm using a lot of Bess Rouse's work today because I think it's a really good example. So a lot of authors articulate their analysis process by 3 steps, and these authors did as well. Now, typically what the 3 steps look like is they look like step 1, we coded our raw data and got first order codes. Step 2, we looked at those first order codes and came up with second order codes. Step 3, we took those second order codes and made aggregate dimensions. There's a sort of very generic description of the process, which honestly doesn't really tell you that much about what the authors really did. So what I think that Kahn and Rouse did really well is they really made it clear what they did in these stages using the actual content of their work. So this is not the entirety, of course, in what they said in each of their steps, It's just the first few sentences. But they say, like, in step 1, during data collection, we noticed that people engaged in at least 2 types of contributions. So we coded the interviews for these 2 types of contributions. So very specific, kind of almost an aha, like we saw that contributions were important. So we focused on those. Then step 2, well, in the course of step 1, they realized that diminishment or being made to feel small was part of it. So in step 2, we focused on descriptions of behaviors and experiences of when and how people were made to feel small. And then in step 3, we re-examined the data to understand how people responded. So it's not just when people were meant to feel small, but how did they respond to that? And so from this description, you can really see how the model was built that they ultimately came up with. It's not just this generic, we did first order coding, we did second order coding. It's a really clear description of the process they used for their particular paper, using the particular things that we're going to see later in the model and the findings. Okay. One of the big questions right now in qualitative research is whether or not to use templates. And in fact, there's a whole issue in organizational research methods coming out about this issue, where lots of different authors have talked about it. And so we do now have templates. This is something that, 3 decades ago, there weren't templates for qualitative research, that people were kind of doing all sorts of different things. But now we do. There's like the Joy method and the Eisenhart method, and they're totally useful. Like, if they fit your project, go for it. If they help you make sense of your data and they help you use your process, I'd say go for it. But they don't fit every project. And so as a reviewer, I would discourage you from looking specifically for a template or being overly wed to, okay, did you use the Joy method? Did you use the Eisenhart method, right? Because there is a lot of sort of trial and error in qualitative research. And I think Mike Pratt and colleagues in this ORM issue talk about bricolage and how we kind of can draw from different qualitative methods and combine them in meaningful ways. So it's not so important that authors stick to a particular method. Although, of course, if they say they use a particular template, it's important that they use that template. So if you're knowledgeable about it, it's fine to make a comment like you didn't really use the Joy method or you didn't really use the Eisenhart method. But what I think you should be more concerned about as a reviewer is, did the authors really describe what was done in a way that you understand and that is reasonable? And that's kind of the points that I've been making up to now, right? Is that in the analysis section, you really need to understand how they got from A to B, and in a perhaps not entirely linear process. So that's what you should be looking for as a reviewer, not so much, did they do this one template that I heard about? Okay, and then my final set of comments is really about going beyond just the analysis section, but also the ability that we have in the findings section to intuit, I guess, a bit about how they did the analysis and how sound it is. So I have 3 points here. The first is just, it's kind of an analysis, sort of a data collection issue, but does there seem to be enough data? And that's the number one question I get when people ask me about qualitative research is like, how many interviews do I need? Well, there's no real answer to that question. I can't tell you with 30, like use a quantitative measure. You need 30 in each box. No, I don't have that answer for you. But what I can tell you is you need to have enough data that you can convincingly make your points and give me a lot of evidence for them. And so a rule of thumb that I tend to use for myself, and I do tend to ask of authors, is 2 to 3 examples in the text, and then 2 to 3 examples in a table later on. So you're getting, between 4 and 6 examples of your main points to show this isn't just one person said this. And they need to come from different people too, right? Or different cases, like shouldn't just be one person reiterating the same point over and over. And this actually gets to another sort of buzzword in qualitative research, which is this idea of theoretical saturation. I see Michael's laughing over there. So theoretical saturation is something that almost every qualitative paper will claim that they have reached, but they don't give any justification for it. It's really easy to say, and we reached theoretical saturation, so we stopped data collection. But I would call on you as a reviewer to push them a little bit and to push authors to really explain how they know they reached theoretical saturation. So first of all, what is it? It's the point at which no new insights are obtained through data collection. No new themes are identified, no issues are arising in the categories that you find, and the categories are really well established and validated. based on Bowen's work. And there's two components to this that I think we should attend to. One is, when did they realize that they got to theoretical contribution, theoretical saturation, and how? So in order to do this, you kind of need to collect data over time. So for example, in the paper that I showed you earlier with that up and down model, we collected over 3 periods. You don't have to do it over time, but one way to do it is to collect data over time. And we really saw in our third phase that no new themes arose. I mean, we got sort of new nuances, and people said things in different ways, but there weren't really some big ahas. So we could say at that point, we felt like we had reached theoretical saturation in terms of, a stage of data collection was not adding new themes. Now, if you don't do data collection over time, you might want to analyze the first, let's say you do 30 interviews, the first 25, and then see if in the next 5 that you analyze, if there were new themes or not. If there are, you probably need to go collect some new data. If they're not, well, then you can say after 25 interviews or however many, no new themes were arising. So I do want authors to be a little more specific about that. And then the other part of this is not just have they gotten to a point where no new categories are emerging, but are the categories that have emerged rich and deep, right? Like, okay, no new categories have emerged, but we only have 2 examples for each of them. Well, that's not great, right? That's not helpful. So the authors do need to be able to show a wealth of data in each of these categories. And that goes back to my previous point about having, 4 to 6-ish at least examples. I mean, really, and you're not going to share all of the examples that you have in your, paper. So, they do need to show you in the data that they really got not just, a bunch of categories, but richness in each of those categories. Okay. So my second point is, does the data say what the authors say it does? This is kind of a beautiful thing about qualitative research, is that you get to see that raw data because they give you quotes and they give you examples, right? And you get to look at it and say, I'm not sure if what the authors say that says is what that quote is actually saying. So you kind of get to do your own little coding experiment or analysis as you read through. And I have to say, I mean, I'm an identity researcher and I get a lot of papers on identity. It's pretty often that I get papers that are all about identity, or presumably all about identity, but I don't see hardly any identity in the quotes, right? There's no people saying, oh, that changed the way I see myself, or this is who I am, or anything really about identity. And so, as a reviewer, I think that's fair to say that that the authors may have been imposing sort of the pre-existing frameworks or frameworks that they wanted on the data and going beyond what the data actually says. And then finally, do you get the whole story? So as I've noted, qualitative analysis is often a function of taking a bunch of data and breaking it down into small component parts and then putting it back together. Like, you come up with all these different categories and they put the categories back together. And oftentimes in manuscripts, you'll see, one person says this part of the model, another person says, speaks to that part of the model, or, one organization did this, another organization did that, but they're all in the same model together. I think what's really effective, and I may be speaking perhaps more to authors even than reviewers at this point, but is really effective if you can put that whole story together with one case. So I'm going to give you a couple of examples. And again, there's a lot of text on these pages. You don't need to read the text. Just, I'm trying to emphasize a point here. So for example, this is what we put in an appendix in one of our papers. It was actually longer than this, but and this is just one person, in one interview talking about their experiences. But we could see in it many of the different components of our model. So role-based image discrepancies, misaligned expectations, impaired collaboration, relationship building. So by putting this in all together, you get the whole story. You get a full picture of how one individual connected all the dots, right? And I think that that's helpful for the reader to see that it's not just, one person said this, one person said that, and then we put it together. It's actually something meaningful as a whole. Another way that I've done this is through tables like this one. In this paper, we found 2 different phases of authenticity. One was about kind of rehearsing, and then the other one was about harmonizing. And so what we did is we took 4 examples and we showed the differences between the 2 phases. So we gave examples of people talking in the harmonizing phase, and we gave examples of people talking in the rehearsing phase. So you could really, as a reader, get a comparison of how these were different for one individual. So it's again, it's not saying that Holly was in the rehearsing phase and Kylie was in the harmonizing phase and then we put them together. No, it's like you see how these individuals as a unit went through this process. Okay, so just some final thoughts here. If you are sent a review to do, it's a qualitative paper and you are not a qualitative reviewer, don't be afraid, okay? Don't be scared, you can do it. And hopefully some of this is helpful to you in that process. You don't need to say in your review that you aren't a qualitative researcher. I can't tell you how many times I've had quant researchers say, well, I'm not a qualitative researcher, so I don't know what I'm talking about. It's like, don't do that, right? I mean, qual researchers, I don't think do that in quantitative papers, but for some reason, in quantitative reviews, quantitative people feel the need to say that. And it's fine if you say it to me as the editor, that's fine. I'm happy to get out your insecurities and all of that. But when you say it to the author, it kind of delegitimates the process. It gives them sort of an excuse to, you know, not listen to your feedback entirely. And your feedback's likely going to be very, very good and helpful. So it's just not necessary to say that. And if you want to get familiar with some of the basics, you know, there's books out there. I don't know if you're going to read a whole book just to review an article, but just a couple of the kind of central ones on different types of analysis. But there's also more and more coming out every day about qualitative data analysis. So I just listed three of the, you know, kind of common ones that people look to. But like I said, there's a whole new issue of ORM coming out that talks about that. So with that, I just want to say thank you, and I'm happy to take any questions that you might have.
Thank you very much, Heather. That was great. And as a predominantly quantitative researcher myself, that resonates so much with me.
Have you been scared of qualitative reviews, Jeremy?
Maybe scared of is the wrong word, but I look forward to them less because it requires more. It requires more time as much as anything else to really invest myself in the reading of it and understanding of it, and yeah, frequently have to go and cross-reference other things that aren't at the top of my head in the way that they might be for some more quantitative stuff. But equally, I can learn a lot from them, and yeah, I completely agree. It's important that anyone's happy to review pretty much anything, obviously not necessarily from a technical standpoint, but especially if you're a content expert.
Right.
So there are a few questions coming up in the chat. First of all, a point from JC Rees-Santhis, great point on the messy process. Also, I think quantitative work, at least non-experimental, is usually much more iterative and circular than it's made out to be in papers. Yes, I think it is. Whether it should be or not is a different question. I'm a strong proponent of exploratory quantitative work. I think there is definitely a place for exploratory work in quantitative with quantitative data, as long as it is reported properly, as long as it's made out to be exploratory and not as we too often, well, I suspect what often happens is people maybe adjusting their prior expectations to match what they've actually found, but that's clearly not good practice. So the more transparent we can be about that, the better, I think. Do you want to come in on that, JC?
Oh, if I can briefly tack on an actual question to that. I'm a computational researcher, but a current leaning has been to add some sort of slicing of interviews kind of to supplement a more inductive exploratory computational approach. And I'm curious if you see ways in which that could go really well or really poorly. If you've seen it in experience, or if you could speculate.
I mean, that's a little more specific, maybe that I could speak to computational in particular, but like there's definitely mixed methods approaches, right, that take a more quant approach and a more qual approach in one paper. And I think I think there's a ton of virtue in that. I have a colleague down the corridor, Mandy O'Neill, who does this very well. But there are difficulties, because oftentimes what happens is one or the other is strong. Like you did really good on the qual part, but the quant part is weak, or the quant part's really strong, but the qual part is weak. Or sometimes it's just two kind of like half studies where neither of them are particularly good. And the authors have hoped, well, if we put them together, maybe they'll make a whole study, right? So I think really to do these joint ventures, if you will, between qualitative and quantitative, you have to be committed to getting them both right. Yeah, I think that's kind of the big takeaway from that. Yeah, and I do actually, if I could just speak to the I'm not going to make any friends with this probably, with the quantitative work being more iterative thing. I think it's funny because a lot of the critics of, or the skeptics, let's say not critics, the skeptics of qualitative work are, oh, it's all subjective, and how, you know, you're coming up with things and you're making it up. And I'm like, well, how'd you come up with your variables? You know, why didn't you choose these 5 other variables? Like, yes, I know we have theory to derive these things, but like they act like there's no subjectivity at all sometimes in quantitative work, and you know, no post hoc analysis that goes, you know, that then becomes a hypothesis. Yeah, so I think that they're not as far apart as sometimes people make them out to be.
Sure, I think that's a very, very fair, valid point. On the subject of mixing methods, question from Adams is, could you speak on management's take on mixing qualitative approaches? I know that in other fields it's often frowned upon, but I do not have a strong grasp on our field's take on it.
Yeah, thank you for that question, Adam. It's a good question. And I think right now there's sort of this renaissance of qualitative methods. And there's a lot of like, we've gone through this process of like, oh, we need a template. Nobody knows what they're doing. It's crazy, to, oh, now we have templates. Awesome. We can just do this. If we do this exact thing, then we'll get published. Right. And now we're kind of on the other end of it, that like, no, like templates are okay. And so, I mean, templates are okay, but they're not necessary. And so I think that like, most qualitative people that are going to be reviewers and editors are open to, yeah, mixing things, doing what's right for your question. You know, like if it takes different approaches and you know, like a partial narrative approach and a partial sort of more typical, you know, coding approach. I really think that there's an openness to that. Of course, I can't promise that every reviewer or every editor will respond positively, but from what I've been reading recently and from my own perspective, yeah, I think as long as it's justified, explained what the intent was, how it was used, I think it's fine.
Great, thank you. And a question from Joyce. Could you talk about translating languages, and she adds in particular, how are quotes added in that perspective? Yeah.
And so I've had this with a couple of like my students who wanted to collect data in other countries and languages, like for example, I don't speak. And you know, you either use, I mean, oftentimes these are students who are completely fluent in both languages, and so they'll often just translate the quotes over. But you can also get, you know, a professional translator to do that. Unfortunately, you know, fortunately or unfortunately, but most of the journals that we publish in are English language. So you will need to get them to English language one way or the other. Right. Now I have seen recently, actually, just in the last few months, like papers that are in other languages, like if there's core like themes or sort of phenomenon that the authors will use the name of that phenomenon in that language, they'll actually put the German version of it in, and then also like, you know, but then talk about what it is in English, just so like for a German speaker, they really understand it, like what they're talking about. I mean, well, I don't speak German, I don't get it, but it is helpful, you know, for somebody who is familiar with that language, because they, you know, have already the associations with that word. Now you can't go overboard with that and have every single phrase in both languages, because nobody's, you know, it's going to get really choppy and hard to follow. But if there are key phrases that to maybe, you know, include both the original and then also, you know, your interpretation or translation of that.
Fantastic. Thank you for that. Any other questions for Heather? Looks like that's probably it for the day. So thank you very much, Heather. And thank you to all of our presenters today, Heather, Betty and Mike, for a wonderful set of presentations. Just before we go, a couple of things to say. First of all, some of you have asked about having slides from today's session, and all three presenters have said they'd be happy to share those. So we'll get those emailed out to everyone. Thanks for that. The final session of the consortium is on Thursday, 10 a.m. Eastern time. And that will be, I think that's being moderated by Genjo. So that will be, it looks like a really interesting session. I hope you'll be able to come to that. For those of you who haven't previously been to the Academy Management meeting, or in particular haven't been to a research methods division part of it, hopefully you'll be able to come along this year. I know that being a member of the research methods division is a prerequisite for being part of this consortium. So hopefully you'll be able to come along to some of the talks or activities this year, maybe next year in person. We'll have to see what happens there. Just want to say also a big thanks once again to Karma for supporting these sessions. Many of you will have been to Karma talks or workshops or short courses before. If you haven't, I strongly recommend checking out what they offer. During the last year in particular, the online offering has really expanded, and it means that there's great options for many people to get involved and learn about new methods and new techniques and all sorts that they might not have done before. Yes, also, thank you. The recording of this will also be made available. I'll find out how that's done at a later stage. But have a good day for the rest of you. And thanks once again to our three presenters, Heather, Betty, and Mike.
And thank you, Jeremy. We really appreciate it.